We're not doing section 4, but I thought I'd let you have a look at it. As you see, instead of having two variables, we have systems of equations with 3 variables. Now there is a way using your calculator, if you have a special calculator, to solve these. And in previous courses I would let students do these using their calculator. So we're not doing any of those. So we're going on to section 5, our last section of chapter 4, where we're going to be dealing with word problems. So basically what we're doing here is to convert English into algebra, in which we're going to use the 2 variables. Now I'm not going to solve these for you, but I will help you to put them into their formula. Now keep in mind, as I look at these in our little booklet here in worksheets, they don't show me any of the formulas. I have to do them all, just like you would have to do it. Then the second phase would be to solve it and then get your answer statement. But I'm going to help you, hopefully, like I did in chapter 2, set up these word problems and give you some techniques. Okay, as we do these, one number, so we'll call that x, is an equal sign, 5 more than the other number. Well, the other number will be y, and then 5 more is plus 5. So there's our first equation. Now here the key is the sum of the numbers is 19. That's pretty straightforward. And you might say, well, what method would I use to solve this? Well, I would think substitution. Set up. Okay, on to number 2. 4 times one number. So 4 times one number is equals 11 more than the second number. Well, here we're defining y as the second number, and it's 11 more. So there's our first equation. And again, when they have this one, that's really nice. The sum of the numbers, 14. Sum of the numbers, 14. Now another easy one. The difference of 2 numbers is 8. Well, the key word there is difference, and there's 8. Now the larger number, which we will now define as x, is 3 more than twice the second number. Well, twice the second number and 3 more. So again, you might say, what method for number 3? Substitution. What method for number 2? Well, you could put it in standard form. I would use standard form because bringing that y over becomes a negative y, and there the y's would cancel out. So again, this is like closure of chapter 4, where you're bringing all your techniques from chapter 2 and other chapters, solving equations, understanding variables, English to algebra, lots of stuff going on. Now as you see these, I've done the answers, but I spent maybe 10-15 minutes thinking about these. This first one was a little bit challenging. It says a motorboat travels this much with the current and this much against the current. So what I said, let the speed of the boat be b, let the speed of the current be c, so b plus c is 22. And then the speed of the boat minus the speed of the current is 8. So there are your 2 equations. and you're going to go 2b, the c's cancel out, equal 30. So the boat speed is 15. Again, once you develop your system of equations, sometimes the answers are easy to get to. Now for number 5, as I look at it, it says a new computer costs $100 more than twice the cost of the older computer. So the new computer I'm going to call X. The old computer cost I'm going to call Y. So X is equal to twice the cost of the old computer plus $100. So again, once you start to identify what you're dealing with, and we can use two variables, hopefully it gets a little easier. And then they're saying the sum of the costs of the new and the old are $2,800. So what would you do here? I'd say substitution probably. All right, number 6 was an easy one. The sum of two numbers is 77. Sum of two numbers 77. Their difference is 7. Number 7. And again, they don't give me these formulas. I'm making them up myself. Hopefully they're correct. Maybe they could be done a little differently. But here they're saying the sum of two numbers, which is this, is equal to twice their difference. So twice their difference is x minus y. That's their difference. Twice their difference. And then the second is if one number is 4 more than the other, find the numbers. So there's x. One number is 4 more than the other. So what I did is I actually worked this one out for you. When we do this and get them in standard form, it becomes this. And then if I transpose the y in standard form, it becomes this. Here the x's cancel out, and I end up with a 2y equals 4. So y equals 2. And if y equals 2, I put the 2 there. 2 plus 4 is 6. So the numbers are 2 and 6. Going on to number 8 here, it says the length of a rectangular garden is 5 meters more than twice the width. So there's the length, twice the width, plus 5 more. And then using perimeter formula, 2 lengths plus 2 widths equal 70. And we had one like this already. With the wind, the rate of the plane plus the rate of the wind gives this miles per hour. The rate of the plane minus the wind flying against it gives you this. Now can you see here they're going to cancel out, and you're going to get 2p equals this sum, and again using elimination or addition for that, substitution for this one. Now here's a very typical kind of problem where you're buying paper. 12 papers and 8 tablets cost this, and then 9 papers and 10 tablets cost this. This probably isn't too difficult to set up, but it's rather tedious to solve because you have to figure out something that's going to cancel out. Probably multiply this by a -10. This will make this a -80. Multiply this by a +8. That'll make that a +80, and then these will cancel out. Again, you have to do each term, and you're not going to get many problems like this on your test, but again, knowing a technique and then just taking your time and checking your work is the key to this. Alright, going on to number 11. Again, you have pounds of horse feed that are 20%. We're going to call that X. And then the horse feed with 5% oats, we'll call that Y. And they're to be mixed to yield 20 pounds of horse feed with 11% oats. So we know then that X plus Y will be 20. That's what we have here. Now again, this is a recipe for doing these mixture problems. So 20% of X plus 5% of Y equals 11% of 20. There are your two equations. I would suggest substitution, and I would also get rid of all my decimals down here. So a little bit of chapter 2 and tying it in with two variables. Alright, here's a very typical one. Movie tickets are this for adults. I'm going to call those tickets A. And $4.50 for children. We'll call those tickets C. And the total receipts were this for this many tickets. So we know the number of adults and the number of children tickets were this. So that's my first equation. A plus C equals this. Now here we have the adult tickets cost this, children's tickets cost this, and this is the total revenue. Now back in chapter 2 we were handling these a little differently. We said we could take a box to represent the total number of tickets, which was 460. And we said we could say that part of this was X and the other part was 460 minus X. Here that we're allowed to use two variables made this is, let's say, A and this is C. And we would handle it a little differently with one variable. But now we have another tool in our toolbox. Now as we go to number 13, we have two bicyclists starting at the same place, riding in opposite directions. One was going 6 miles an hour faster than the other. And they were traveling 3 hours. So the rate of this person is 3 hours times its rate. This was 3 hours times the rate plus 6. And we had done this one before. So 3r plus 3 times r plus 6 is your total distance of 84 miles. So here, instead of using two variables, we're just using one. And this is a technique we went over in chapter 2. Going on to number 14 now, a triangle. And again, we did this before. It looks very familiar. This is our second angle. One angle is twice the second angle. And the third angle is 20 less than the second angle. And then the sum of the angles equal 180. Okay, we're keeping this tape a little short, but I've spent a lot of time with pencil and paper working on getting formulas for this. I'm not just sitting down and writing them, although a few I did that way. All right, number 15 was particularly tricky because you had to try to identify the sides. And once I did that, I said that S is the second side here. This would be the third side, and then that's the fourth side. And figuring that out was rather tedious. Anyway, that's the perimeter. Now, number 16 wasn't too bad because it was the sum of, well, first, one number is 4 more than the second number. That was easy. And then twice the second, you had to remember, was y, equals the first increased by 3. So again, substitution would be a good method here. We've done 17 before. In fact, it was done twice. They're just giving us another one to see if we remember. Now, I got to remember, we skipped section 4.4 with 3 variables. And so we're going to just skip that one. Now here's a salesperson receives a salary of this with 10% of their sales, or a salary of this with 15% of their sales. How many sales per week make both arrangements pay the same amount? So here we set this one up again from chapter 3. Y equals this. And we set the second one up as y equals this. And then the technique to solve it would be y equals y, just have this equal that, and then solve for x. And that will give you the amount of sales. And number 20 is very similar to what we've done already. Back in chapter 2, we just used one variable, where we divided this into 2 parts, and that's using 2 variables, make it a little easier. X plus y equals this, and then 3% of x plus 7% of y gives you 5% of the 120. Again, get rid of the decimals, use probably substitution, solve for one of the letters, and that will wrap it up. Remember, the answers are available, and you want to practice here putting English into algebra. And good luck with your Chapter 4 test.